Hi students, let's look at this question here, which was taken from the year 1986, paper 2, question 10 on hypothesis testing. So let's see how we can do this proficiently. So the length of a string in the balls of a string is made by a particular manufacturer, has this mean of mu and variance of 27.4 square meters. So the manufacturer claims that mu is 300 and a random sample of 100 is taken and the sum of the length is found to be s meters. Okay, so I think the first thing is to understand that this is the population mean. So this, because we wouldn't know that this is normally distributed. So what you could write just variance x and expectation of x. Okay, so just write it down. So this case here, expectation of x was given by mu, variance of x is given by 27. You can't write normally distributed. Okay, so then we were told that s is the sum of all data points. So you sum everything up, and that will be your s. So this case here is sum of all data points, and also n is 100. We have 100 data points there. Okay, so if s is 29920, test whether it provides a significance level at 3% that the manufacturer's claim overstates the value of mu. Okay, great. So let's look at this. So first part, I think we just set up this question first. So this case here, we just let x be the length of a random ball of string in meters and mu be the population mean length of a random ball of string. So we know that mu naught, which is a common belief, that this is 300 meters, then after which h1. Now the thing about h1 is we know that you won't overstate now is pointing towards the left, but even if you do not know, what you should do is just look at the bar x. You know that this is one tail, it's not a two tail, whether it's a one tail thing. So what we need is a summation of x over 100. In this case here is just s. We are given that s is 29920 divided by 100, that will be 299.2. Okay, then after which what we need is alpha percentage is 3%. Okay, then sigma square, which is a variance, is actually 27.4 and n is 100. Okay, that's what we need to do. All right, so just set up. So under h0, I'm going to write out under h0, I'm going to use a z-test. Of course, I'm going to use p-value method. But I'm going to just standardize, okay? Z bar x minus mu over sigma square over n. Then put this as standardized to 0, 1. And approximately by... Okay, so obviously, if you do not want to standardize, I understand you can. But it's just choose one of the method. So usually I'll just standardize because it's just a one-size-fits-all theorem. Since n equals to 100 is large. Okay, you need to use central limit theorem here because we just need to make sure that the sample mean is normally distributed before we carry out the test. The population we do not know is whether it's normal or not, but the thing is because n is 100, so we can be sure that sample mean is already normally distributed by CLT. So from GC, we're just going to calculate this. Calculate the p-value because p-value method is quite easier to get. So just bring out GC, just key in all this information. So what we do is go to stats, then we go to test, the z-test, then the data. I'm pretty sure this mu is 300, so put this as 300. Then sigma is square root of 27.4. Just remember, this sigma is a population standard deviation, so please don't. So this is 29.2, and after which the n will be 100. I'm counting towards the left tail, then this is it. So my p-value is 0.63216. so this p-value 0.063216, which is more than 0.03. So concluding statement is that we do not reject h0. At 3% level of significance, we do not have sufficient evidence to state that the manufacturer overstates the value of mu. Okay, so that's that. Then we look at the part B, find a set of value of s for which the test concludes the manufacturer's claim to overstate. Okay, now in other words, now we are carrying the same test, but now we're using 5% on the left tail. Okay, so let's look at that part B. you can't use p-value method for this, so you have to use the algebraic method or the classical method. All right, so here now h now we are looking at, it's the same test altogether. It's just that we change it alpha percentage to 5%. Okay, so we reject it on the right. Now remember what happens is this, the closer you are to the true mean, which is the, okay, I'm going to use standardized curve. This is where h0 is true. The closer you are to the mean here, h0 is more true. Okay, so but in fact the whole normal curve is, we just give the benefit of the doubt. We always assume that h0 is true for the entire thing. Okay, so then after that, what we need to understand is we cut out 5% on the lower tail, and this will be our rejection zone. So this is 5%, and this over here is our z critical. Okay, so just find the z critical. So this is the reason why I usually use the standardized form, because it's easier. So from GC, z critical would be, we just need to inverse norm distribution, inverse norm number 3, and I'm going to put 0.05 on the left, enter it. There will be negative 1.64485, negative 1.64485. Then what we need to do is, since we need to reject h0, right, because it was said that we conclude that manufacturers claim overstates, so meaning to say we favor h now. We favor h now, and we want to reject reject, what do you call it, his claim. Okay, so we just say we reject h now. You want to reject h now. Sorry, we want to favor the hypothesis of lesser than 300. Okay, so this case here, what we have is essentially we just use the boundary, the critical. So the z stats should be, so to reject h now, what we have is z stats. Okay, have we at most the z critical. So it doesn't, I don't think it's strict, the equal sign, it doesn't matter. So it really depends on your school whether they put equal signs or not, but just put equal sign if you want to. Yeah, so this case we know that it's bar x divided by 300 by standardization. Okay, standardization, the z stats will be this over here, 1.64485. So what I do is basically I just standardize using the same data point. Now s is the unknown. Okay, s is the unknown, so we want to find the range of s. So just note that bar x is equal to s over 100. Okay, we just need to solve that. So this case, I'm gonna just do normal linear inequality, which is 1.64485 to 7.4 over 100, x bar 300, 85. King calculator, x bar will be so x bar is 1 over 100, then king here will be 299.13900. So s will be at most 29913.9. They want it in 1 dp, so leave it in 1 dp. Okay, so that's about it. So the last one, state giving a reason whether it's necessary for the length, meaning to say, do we need to assume the population is normally distributed, right? That's the thing. For the test to be valid, but the answer is no, because sample size is big enough. Okay, so that's the reason. So it's not necessary, because it's not necessary for the population to be normally distributed, because n is large, the sample size is large. So as long as our sample mean is, we could use CLT to carry out the test, so we don't need to. Okay, so that's how you do this questionnaire proficiently. If you have any questions at all, please let us know, and I'll see you in the next question.